Good afternoon, Dr. Colin. I'll take this opportunity to show you question number 2 from assignment 11, regression. Let me share my screen. So question number 2, transform the continuous variable for grad school into categorical variable with 3 equal groups. New categorical variable to predict API and report the predicted mean of API for 3 categories of grad school. So the data, this will be the regression between API and the grad school. So the grad school is the percentage of the parent who went to the higher grad school studies. So let me start with descriptive statistics for grad school. So for grad school descriptive, the variable is grad school. We selected all the statistical sample size that shows valid, missing, mean, cut point for 3 equal subgroups, standard deviation, minimum, max, and that shows the descriptive statistics for the grad school. Now the next step will be the linear regression. So for linear regression, we select the dependent variable is API 00 scale. Now it cannot be covariates because we need the grad school into 3 categorical subgroups. So for that reason, we will go back to the data. I have inserted the column on grad school. So I use the code which you provided by using the descriptive statistics, the values and the range between this formula kept it nominal column type, and that yield the label editor from 0, 1, 2. So these values will be used as a group 0, 1, and 2. So linear regression. Now the grad school 3 category, and we selected the model for grad school 3 statistics shows estimate confidence interval for 95% tolerance and VFI model fit descriptive. We kept the P value for method specification and plot. We have the margin effect and confidence interval plot. So model. So the model M1, which is grad school, that shows 0.634 and the R square that shows 0.482. So this shows a strong correlation, and a higher the value is, it has a larger effect size. And when RMSE, when the value is lower, this shows a better fit model. So the sample linear regression found 40% of the variation in the API can be explained by the variation in the grad school subcategories. Next is ANOVA. So the ANOVA model, as you can see, the ANOVA is the P is less than 0.05, which means this model is significant, and with the degree of freedom 2,397 is equal to 133.633. So next is coefficient table. In coefficient table, you saw the M0 API, the intercept value is 647.622, and the M1, this will show 3 different numbers or based on the group 0, 1, and 2 for grad school. So the slope or A, the Y is equal to A, which is the intercept for the Y, which is 561.138 for group 0, and for group 1, it's 64.180, and for group 2 is 210.182. So we have used, so the next will be for the collinearity statistics, the tolerance and the VIF is within 1. So that means there is no correlation or multi-collinearity. and the p-value is less than 0.05. So the results of the coefficient table shows the grad school subcategories were positive, indicating that the academic performance increases with each unit of the grad school. So the group 0 is which is 0, the API is 561.114, and for group 1 the same API A, which is the intercept for y, it added to the slope 64.18, which is 625.32, and for group 2 it's get added by 210.18, 771.32. So this has in the margin plot, as you can see in the margin plot, the x-axis is grad school, the three categories of grad school, and you have the API scores. So as you can see, each group, the score, API score, as go up, as you explained us in the t value. It's not a straight line, it's like inclined slope by using the coefficient in the coefficient and the t values. And also the last will be the descriptive statistics, which shows the mean standard deviation.